Hi everyone, this will be the last video of derivative series, and in this video we're going to talk about application of derivative. And if you ask me truly, I only understood derivative once I understood its application, and then I searched my back through, like I back propagated myself to understand derivative in a more better way, right? Uh, and there are so many examples we have in our real world for derivatives, like in field of AI, in field of quantum computing, in field of optimization. Like there are so many examples, and but in the school you might not find that kind of examples taught to you, but those are really simple. And here I'm going to show one of the example, not probably from the machine learning side, because that will be a different thing for you guys. As a beginner, I won't suggest jumping into that example. But once this video ends, then the future videos we're gonna use a lot of derivative application actually with codes and all. So I hope you're there, and let's continue with the video. So we have a problem statement. That problem statement is that you have a business, and in business you must have learned about profit and loss, right? And profit is calculated by selling price minus cost price. Simple formula, right? You must have learned in your arithmetic class in middle school or something like this. And selling price is basically the price which you sell, and the cost price is whatever the cost you like cover making that product, right? Let's say I'm selling something, and there is one more formula to cost price can be divided into two things. One is called fixed cost, right? Just like we have fixed cost in, like, let's say your mobile recharge or the internet recharge or something. There will be fixed cost. Hey, per month you have to pay this much money. And then there is a labor cost or variable cost, you can say, which change. So after your limit of 2 GB per day ends or per month ends or something, then whatever the extra GB you use, then additive charges is added or something like this, you can think. So the cost price is made from two called. One is called fixed cost, one is variable cost. We call it labor cost, right? You can say that as well. And so the price of one product is basically 20. So if you want to know the selling price of that product is 2x, we can write 20x basically, right? So 20x means if I put x is equal to 1, for one product the price will be 20. For two products it will be 40 or something like this. Then the cost price of those things, right? For one product, this is the formula to know the cost price. So if you put 1, it become 1 square, 10 into 1 become 10, 10 plus 11. So 11. So a single product, it will take 11 rupees to make it, and if you sell it for 20 rupees, you will get the profit of 9 rupees, right? So this is a number. Instead of x, you can apply 2. If you put 2 over there, you will get some value of profit. Like if you subtract the selling price and the cost price. And that is this is our profit function, you can say, right? Where I could input the number of product I'm making, and I'll get to know what is my profit over there, right? Profit margin, we can say. How derivative is required. So I want to ask you a question. Can you tell me how much product I make? What is the number of product X? What is the number of product I make where I will have maximum profit, right? One of the solution is that you randomly try X is equal to 1, get some value, X is equal to 2, something like this, 4, 5, 6, 7. Then you will see a graph. In the graph, you can see which is the highest point, right? And that will give you a solution. But this is what is a brute force method, I would say. This is not the optimal way. There is no science used. You are just using a lot of labor to get the answer, right? And actually we can do that. So you can see in the screen, this axis tells me the profit, and if this horizontal axis tells me the number of products I make. If I make one, I'll get like how much? Some around 6 or 7 profit over here, right? For 2, I'll get around 10 or something, 11, 12, something like this. So for different number of product, I'm getting the profit. And as you can see, the question was to tell me at which point I was getting the highest profit, right? So you can see the graph is going, the highest point in this graph is this point. It is somewhere around 25, right? Somewhere around 25. And it what is the number is X. So basically, what is happening with the product or something is that let's say your product has one storeroom, right? And you generated five product. Let's say you're generating 5 cars. In that go down or store, you can only store 5 cars. After that 5, you have to actually rent another place because you don't have the space to keep the 6th product or 7th product. So now that is also added into the cost part. For 5, you are okay because you have a storeroom which is already allotted for your business. There you can keep your 5 product. So that way the cost is maintained. But as soon as it goes 6, that's why it's, if you see, the profit is going down, because once after it start making the product number of products 6, 7, 8 something, there you need extra space and you don't have space at your go down or storeroom or something. Then you have to actually rent another place. So there the prices can go. So this example you can say there is a sweet spot at 5 where I will get the most profit, right? And this is the brute force method where you draw the graph and see it. But how we can use derivatives to get the answer, right? That is the interesting part. That's why you are here as well. So if you see, what do you say, slope at different points, right? Slope at from 0 to 1 or something, or from 1 to 2. If you see slope at from 1 to 2, it's 7. Means basically this graph, what it tells, this is a profit graph, and this is so rate of change of profit with respect to the product, right? If I have to write in a derivative form, this slope is basically telling me rate of how fast the rate will change if I make product 1 or 2, something like this. So it is 7, like the price, the profit you will become very higher. And if I take slope from 2 to 3, right, then it is not that profitable at 5. Initially it was very profitable, then it became 5, right? So basically when you make 2 to 3 product, what will be the profit, what will the rate of change of profit with respect to that number of product? So that will be 5, right? And what is the best part is that when you find slope or the rate of profit at different numbers, you'll see as soon as I go, rate is going slower. Basically at this point becomes 0, 1. So if you see at the 5 points, this line is a curve. If I could just draw a tangent line, it will be very straight. So there will be no value in rise or run. So basically 0 upon 0. And then the slope at this point, basically the rate of change of profit with respect to the number of product, will become 0. At this point, where actually the profit is highest, slope is 0. Whenever you are trying to, so this is a maxima problem where we're trying to maximize the profit, right? What is the number? So at point where the slope is 0, there is a high chance that your solution would be maximum over there, right? A function, profit function or any function, and you find a point where the slope is 0, there is a very high chance that you will see a profit, right? That is what I'm saying. And there is another case, let's say this curve was, instead of like this, it was down below like this, like a parabola, right? Then that will be the lowest point. So there we have two things. When we see a function, visualize a function, then you will understand that is it a maxima function or a minima function. Minima function will be mostly like this, and they will also have slope 0. So to know if that solution is a maximum minimum, simply you just assign the slope 0 over there, and you can solve the equation, and then probably you will understand what is the best number which will give you maximum profit. So that we can do. And you can see for 5 and 6, now the slope rate of profit is decreasing. Basically it is going minus. Now it is actually decreasing your profit, right? 6 to 8, then 8 to 9 or something like this, then 9 to 10 or 10 to 11, right? And you see minus 7. Now the slope is negative. Basically the rate of change is negative. That means at this point you will lose the profit if you keep on making 8 product, 9 product, 10 product or something like this, right? You will not have that much profit. And after 10, it becomes 0, and then it might go in negative, right? So that is the solution. So what we can do, so this is a profit function. If I just assign this profit function, basically what we can say is called rate of change of profit with respect to S is equal to this. And I know that at which point this rate of change, like actually I missed D over here. It should be D over there. D D example, right? Because we wanted to see the small change, right? So D profit by dx will equal to 10x minus x square, right? What is saying that this is a, if I just take derivative and if I assign this part to 0, right? If I assign this part to 0 and if I solve for x, it will exactly tell me the x point where the slope is 0, and that point will also tell how this might be a profitable point or it will be a loss point, right? But in this case it is a profitable point. If you again derive this thing, this is out, okay, so now you have understood how we can find the maximum point, right? If you just assign, as we know that derivative at that point will be 0, and if you solve this, you'll get your x value as a solution. If I solve it, I'll get x is equal to 5, right? And this we can also prove using the graph as well. So that way we'll get the solution. And one point is that in this example, we could see the graph was like for maximum, but there will be a chance where the problem, how would you know without drawing the graph? So what you can do, you can, this is a bonus part. If you don't even understand, that's okay. We don't require the over here. The bonus part is that if you again derive this equation, right, d by dx, if you take another, so after first differentiation, I got 10 minus 2x, right? When I derive this function and then assign this value 0, when you first differentiate this thing, right? When you first, again if you differentiate, you will get minus 2. So whenever you get your term, whatever the differentiation value in minus, if you get a differentiation value in minus, then probably you have a maximum point. Or if you get a derivative output in a plus, then it becomes a minima point. Because if you know there in the minima, if a function is a minima, like where it is going, basically you will see loss or something like this. At that point, slope will be 0, and the surrounding values will be positive, right? So that is a bonus part. I hope you understood how we solved this, how we this got. So at this x, I'll get a maximum profit, and if you input this x back to this formula, it'll become 20 minus 20 into 5 becomes 100, 100 minus 50 plus 25 something. If you subtract, somewhere around 25 or something you will get. So that is the best profit you can get. If you increase this x plus 6, you will decrease your profit somewhere around 22 or some 2 or 21 you will get. If you increase x to 4, then also you'll around 20 you will get, but only profit of 20-25 margin will only get when you actually input 5. And how we solved it? By using the differentiation. So what differentiation is saying over here? The rate of change of profit with respect to the number of products I'm making, right? And where this rate will become 0, at where the profit is maximum, right? At that point where the change is, there is no change is happening, and after that there is, like, if you visualize this, at what point, like at what situation your rate of change of profit becomes slow, 0, very near to 0, right? It might be a curve where it is the highest, or it might curve the lowest. So I think this paints a good picture for you. So that's what it is. I hope you understood the application of derivative. There will be more examples. This is the tiny example which we have done, and the goal of whole the thing which the learned derivative which we have done is to make you understand how machine learning model work, how gradient descent work, right? So there we can actually use this maxima minima solution and see how derivatives will help there to create a model and how to give knowledge to an AI model or something like this. So I hope you guys will be there in that video as well. So see you in that one. Do let me know any comment, reviews, any changes you want or something like this, anything which you haven't understood, or any feedback you want to send me. That would really help me and really motivate me to make more videos like this. So see you in the next one.